It's a great pleasure and a great honor to introduce our invited speaker, Professor Deborah McGuinness, whose reputation precedes her. So for those who don't know, Deborah has been a pioneer in knowledge representation, reasoning, the web, and also she has strong connections with our field, with Neurosymbolic AI, that she's going to touch upon today. Deborah has had a long and successful career, first at AT&T Bell Labs, which was one of the prominent, or if not the most prominent research place to be in computer science, and Deborah was there. She also worked at the Stanford Knowledge Systems Lab, at the AI Lab at Stanford for several years, from 1998 to 2007, where she was co-director and also senior research scientist, and she became the acting director of the lab at Stanford. She later joined as an endowed constellation chair within the Tetherless World Constellation at the RPI. She was the founding director of the Web Science Research Center, the director of the Health Analytics and Institute for Data Exploration and Applications. Deborah is also a consultant, CEO of her own company, and she's been a leader in the field for many, many years, and it's a great honor for us to have your time here and wisdom today, Deborah. Thank you so much.
Thanks for that kind introduction, and I am super thrilled to be here. This is actually my first NeSy, which I find actually kind of shocking given how long this conference series has been going on, but I've been doing work in this area for a while. So you might see on the agenda that I had one title, Graph-Powered Hybrid AI, because that's the name of a class that I'm teaching this term, literally started last week. But you know, when I give invited talks these days, I just have to make sure, yes, I started it. I try to think up, and I try to abstract up and leave some, hopefully, pearls of wisdom and some advice about how we might move forward. So my broader title is Adapting Our Approaches in today's AI evolving landscape, which, you know, is moving at kind of light speed. So you heard a little bit about my background. I come from GoFi, good old-fashioned AI. Oh, did it go away? Okay, there's probably, hopefully it'll come back. But I see somebody doing something back there. Do I need to do something up here? No, okay. Well, I'll give some background of the history of GoFi, my history of GoFi. So I made my name in ontologies, knowledge representation and reasoning, knowledge graphs before that phrase was like super popular, provenance, applications like precision medicine, all sorts of knowledge portals, explanation. Okay, it's coming back, we think. And today, I do hybrid everything. When I was at Bell Labs, I was solidly in description logics. DL used to stand for description logics. Now, oh, yes, we're back. Now it is most commonly referred to as deep learning. But when I went to Stanford, I called myself Dr. Ontology because ontologies kind of drove everything. Now at Stanford, I call myself Dr. Hybrid because I don't think I do anything that's not hybrid. I have some pictures up here that are indicative of my background, but they also might have a message for this audience. So, for example, that's interesting. It's not showing up there. Oh, maybe. Yes, there. Okay. So this ontology spectrum, I'm a little bit famous for this. I did this not alone. So it came out of a AAAI panel, ontologies panel in 1999, where 5 of us designated ontology experts said, well, the night before we should at least agree on what we're going to claim to be the definition of an ontology. And of course, there was a spectrum of definitions, and we decided to at least aim to be inclusive. So even a controlled vocabulary, even the things at the far left of the spectrum, many people would allow to be kind of the less expressive end of ontologies, and then moving through the right where you can count on inference, going all the way up to have very expressive representations of knowledge. And one of the reasons that I bring this up I used the spectrum and I wrote a paper and I took every single point on the spectrum and said, even if all you have is a controlled vocabulary, look, you can have benefits, these kind of benefits, and here's an application that does it. I bring this up because neurosymbolic, what's your definition of neurosymbolic? Well, there's a lot of definitions there. Maybe it's time for this community. I've seen papers, and Pascal, who's sadly not here today, is one of those people who have written papers on this from maybe more of a formal perspective. But I think this angle of being inclusive about what neurosymbolic might be, and then giving examples at all different points on that spectrum where neurosymbolic can make a difference, I think that would be useful for this field. And I'm looking at the person who just came in the door because he's got a poster out there that starts to aim in this direction, which I think would be useful to do. And I wouldn't do it alone, despite the fact that he's got some nice groundwork. I would contemplate it as a community that we get together and provide examples at all sorts of places in the neurosymbolic spectrum. This ontology spectrum was just on an expressiveness perspective. Since then, people have done two-dimensional and n-dimensional perspectives on it. We might have to do that in neurosymbolic, but it might be instructive for the field. And I look around and see this is a nice size audience, but given the hotness and the potential of neurosymbolic in today's crazy AI times, I would have expected a few more people here. And maybe it's because we haven't given pragmatic advice, pragmatic examples of where the world can have see a difference. So this was one of the places that could be instructive. I have maybe not so debatably made a career of making smart data portals in all sorts of areas. And one of the reasons that actually is beneficial is I can get funding from a lot of different places, whether it's from the National Institute of Environmental Health Science for the Human Health Exposure and Analysis Repository, whether it's from NSF for nanoparticles and metamaterials, whether it's for AT&T for configuration examples, building big pieces of transmission equipment. So it gives you a lot of different flexibility, and you can often show a bottom line impact for dollars and cents that might make a difference. And you might, actually I don't have them up here, but you might then apply, submit a paper for innovative applications of artificial intelligence and win deployed application awards and show bottom line impact for companies or other funders. Another thing that I have left a little bit of legacy for is the Semantic Web Working Symposium. Started the first workshop that I'm aware of in 2001 at Stanford. It ended up kicking off the entire International Semantic Web Conference series. I think we're up to 21 years or something now. So sometimes you can start something, see it blossom, and then, kind of create a whole field, which I think, it's not that neurosymbolic is new, but the opportunities for neurosymbolic, I think, are exploding. One more thing, because one of the other messages that I'm going to leave with is think about your passions when you think about what to do. So I took a graduate class. I went straight from my undergraduate degree, Bell Labs. I wasn't sure whether I wanted to go into academics or industry, but they came along and said, hey, we'll pay for your future education, and as long as you get into one of the 8 best computer science departments that we've identified in the country, we'll pay for the master's and later the PhD. I took a class in expert systems, and I'm like, well, what can I be my own expert in? Ooh, wine and food pairings. So I'm a wine connoisseur. And I said, I'm often asked to suggest properties of a wine that you might have to go with a dish. So like if you're going to have red meat, you might consider red, full or medium-bodied dry wine. So I made this little ontology for that back in the 80s, released it publicly, turned it into examples that demonstrated these enormous configuration systems that we did at Bell Labs that used description logics, but I was bored when I was given the talks. It was configuring things that had J21 and 987243 as a part number. I'm like, how can I explain this when I, the speaker, I'm not so interested? So I looked at all the inferences that I was doing, and I mapped it over into my wines and foods examples, and then I could give my talks to anybody. So, and then I released it to the world. That ontology has been at the basis of widely cited Ontologies 101. I think it's got more than 10,000 citations, translated into 5 languages. It just kind of makes it out there when you not only make your technical points, but you make them accessible to the world. And then also a lot of people, when you go visit them, they take you to good restaurants and they bring you good wine. So super good benefits. So why am I here? I started with AI many years ago. I took my first graduate class when I was an undergrad at Duke. Duke didn't have an undergraduate class in AI. So I just took the grad class because, what else are you going to do when you're a triple major, overachieving student? But I found that AI met my passions of exploring how people think, potentially how they understand, and how machines and computers might help. And I think that's still true today, and that's why I'm still in this field, going strong and loving it. And some questions that I think are worth exploring in this talk, or that I decided to explore in this talk, are how might we view the AI landscape, both from a historical perspective as well as from today's perspective, and how might that inform our approaches moving forward? A little bit picking up on Guy's question of, are some old ideas worth re-exploring? I think the answer is definitively yes. And are there lessons to be learned from those previous directions that might be broadly applicable? And then what directions might we take today? And I have to say, I was like super welcomed when that poster out there said, ask your ontology, natural language, answers with evidence. Yes, that's been my passion since forever. So I think that hackathon later today is going to be pretty interesting. So now I'm going to give a little bit of perspective. So my first international publication was on some neurosymbolic work on a system called conceptual retrieval using connectionist style, using a Boltzmann machine, connectionist simulator, microclone from Mark Durthik, who was at CMU at the time, to support similarity-based reasoning in frame systems or in description logics. So we mapped those description logic style representations to microfeatures that are implemented and weighted by directional links. And you could enable all sorts of reasoning, positive and negative. You could have pretty expressive representations. And then because I'm a young grad student at the time, I built the ontology. I took some naturally occurring abstracts, encoded them into a knowledge base, and we queried for conceptually close individuals like object-oriented programming languages implemented in language like interlisp. But we ran into scale problems using our $100,000 Symbolics 3670 with a wildly big memory, 8 megabytes. And then we published it in an information retrieval conference. So 1988, what about this architecture looks similar? Isn't it, it's kind of where we are today. We didn't have the number of parameters. I used a simulator. I used this, actually this was a little smaller than the one that I used. It was like bigger than this. Ran for a weekend to go over a tiny little knowledge base to answer questions like, do conceptual retrieval. And then we got correct answers, so I got positive responses, but trying to publish in the information retrieval literature when you didn't scale was not a good place. But our conclusion, this is a direct quote, was some form of automated tuning and a real connectionist machine rather than a slow simulator. This approach could provide a good basis for conceptual retrieval. So now, 35 plus years later, we have a lot of automated tuning. We have tools from academics and industry providing neurosymbolic architectures. I'm looking at Jan's up in the back. I took that picture from his company's website about, a neurosymbolic architecture. So the time is right. It only took 35 years, but the time is right to really make a difference. So AI in the world is changing. This is from a much more recent paper. So I and some of the other people my age have lived through the AI summers, the AI winters, the AI overhype, but nothing like the overhype of today. But things are changing not just with new hardware, not just with new tools, but also platforms. But now things are different. The barriers to entry are essentially non-existent. If you can either speak or write a query in natural language, you can get some answers, maybe useful, maybe not, but you'd have to evaluate them. But one big thing is results are noticeable to some funders. So the world, in some ways, is our oyster. This is a little timeline that we did for common sense AI history of the web. That kind of the top pieces are solidly symbolic, but as you come around, you get to more of the foundations of what we see today in the neurosymbolic and, with large language models and embeddings. It's going to continue. The one thing that we can definitely see is that it will continue. I have been giving a series of talks on what do we do in this evolving landscape from a funding perspective, from a technology perspective. Knowledge graphs are, near and dear to my heart. I gave a talk at the Knowledge Graph conference, and one of the things that I loved was they had an artist sit in the room and in real time draw a picture of my talk. So I'm going to say a lot of the same things. Here it's 2 years, a year and a half later after this talk, but the AI landscape is still changing. Large language models are still changing everything. Do they understand? Well, they have some impressive results, but I don't think they really understand. I think most of you think they don't really understand. But how do we use what they do well? How do we describe what they do well? How do we figure out where the edges of what they do well are so that we let people know when not to use them? How do we really identify those limitations? And is today's AI a threat or opportunity? Well, the answer is both, of course. The one answer is collaborate. Collaborate with the tools, collaborate with other people, create exploration sandboxes to evaluate what's out there. And one of the messages, I'm going to talk a little bit about metrics. I think benchmarks are everywhere, but they're not the be-all and end-all. We need to have creation of exploration sandboxes to see what we can do and what we can't do. And when we have people like Amit Sangal at Google at the time do an interesting blog, the Things Not Strings blog, he made knowledge graphs take off. Knowledge graphs, the phrase, has been around since the 80s, but the technology, the ideas have been around at least since Bill Woods and Ron Brockman in the 60s and 70s, semantic networks earlier. But when you have somebody who has the ear of the world, your technology can explode. So we need better communicators as well. We also need to survey the landscape. One of the things that I do is I always try to do it at least once a year, to go to some industry conference and walk kind of an exhibit floor and see what people who are actually making money off the technology are selling, and see what they think see where they think they're going. You can love or hate these hype cycles from Gartner, but I find them at least a little bit informative. It's interesting that Neurosymbolic is moving up the innovation trigger area. Gen AI is solidly in the trough of disillusionment, but still people are using it. And, I really like a lot of podcasts. Well, I listen to too many podcasts, but one of the podcasts that I listen to is Reid Hoffman's Possibilities podcast. And one of the things that he says often is, if you're not finding a way to make large language models do something useful for you, you're not looking hard enough. I've been shocked at how much they can do, and depressingly shocked sometimes at what they can do. But I also am thrilled about technologies like knowledge graphs coming up that slope of enlightenment. My phone is starting to ring again on technologies of like, can you build a knowledge graph for me? Actually, when I was at Stanford, my phone was ringing off the hook saying, can't you build an ontology for me to solve all my problems? And I'm like, well, how much money have you got? I'll build you something that'll do something good for you. But lots of people didn't even know what they wanted to do with them. We also see that with knowledge graphs, but at least my phone is ringing for people wanting to build knowledge graphs. And I think this is accurate. So this is from 2 years ago. It was lower down the hill. It was further up the peak of inflated expectations. At one point, we were going to have Gary Marcus give a talk tomorrow. I was expecting him to be talking about these inflated expectations out the wazoo, which is one of his shticks. Sad that he ended up not being able to make it. But still, how do we leverage what's good about them, and how do we not get taken down when they're bad? But let's also observe and leverage what industry meetings when we can. I tried to crash the Gartner meeting this year, but I didn't want to pay the $5,000 to get in the door to walk the exhibit floor, so I walked the exhibitors who were outside. But often I managed to talk my way into, like, Enterprise Data World. Friends run it, so I usually can get a day exhibit hall pass just to see what's out there. And when I can't do that, then I talk to my friends like Juan Cicada, who goes now everywhere, now that his company got acquired by ServiceNow. But, he goes to the Gartner meetings, and he goes to the enterprise data management meetings, and he runs all these listening tours about what people need, and he goes to Snowflake and everything. So I try to stay up with what industry is doing so that I can also try to figure out gaps and places that make sense for I and my group to work. So, what do we consider when we're deciding what to do? I think we always should consider our passions and strengths. So this might be a different answer for everyone, but for me, I still love good old-fashioned AI. Still totally in love with knowledge graphs and ontologies. I still think everybody, well, not everybody, a lot of people need explanation, but also I find energy by working in interdisciplinary settings and in learning new things. So how do I leverage that? And I attract people in my group who like to do this as well. So I want to try to play there. I think we always need to survey the landscape and consider the competition. Like when I have a student who comes up to me and says, I want to do X, and then I say, doesn't that sound exactly where OpenAI has got 100 people trying to do the same thing? Maybe we don't play there. Maybe we move a little bit. And by the way, I don't have enough hardware to compete with the environments that they're working in. And then let's have creative uses for emerging technologies. So I wasn't trained in machine learning, but when I was at Stanford, at one point, I had $4 million of government-sponsored research money for learning programs. I didn't really do the learning, but I did explanation of hybrid learning systems because learning was hot. And then, I became a person who went and gave talks on learning. Now, I don't think I don't think many people ignore LLMs. LLMs are integrated into pieces of pretty much everything I do, even when, for example, I wrote an expert witness report, and I used LLMs to help me do background surveys with citations, and of course I checked everything. And of course I was an expert using the tool, so one of the things that I could do is I could identify when it was missing something, because that's not something that your tools can always do, but when in expert hands, it often can be done. And then what gaps are out there and what gaps might make sense to tackle, either because they're both fun and because I don't know of 100 other people who are trying to tackle them. And then there's some number of younger people in the audience. The Heilmeyer challenges came out, I believe, in the late 70s, and I've got a slide on them. But they still work today, so why are we doing this now? So we should always consider these because somebody's going to have to pay for your research. I mean, you're at least going to pay in your time, but your advisor might pay trying to support you, and some funder needs to come by and keep the research going. So consider that funding landscape, but also consider emerging technical policies. So, it's a wild world that now my friends sometimes show up above the fold, like on the front page of the New York Times with their new technology. We're not living in isolation anymore, but now people are looking at our work and thinking, oh, maybe we should pause AI for 6 months. Maybe like a bunch of my AI fellow friends signed that document. And I thought about it when it came out, and I'm like, is this going to be a valuable thing to do? What's going to happen if I do sign it? What's going to happen if good players pause it and bad players don't? What are the policies that are likely to emerge? And you're starting to see legislation. Actually, I don't have those slides in this deck, but I often pick up, the current policies that the UK is going to put out that, even though I work here and I'm largely funded here, I need to be aware of that kind of stuff. And then, are there interdisciplinary or combinations that make sense now that might not have made sense before? Maybe from a scaling perspective, maybe from a technological perspective, maybe because AlphaFold exists now and didn't before. Just watching my time. So, what's different now that might make sense? And then a lot of my people, I've always been a little bit human-centered, like, humans are going to use this stuff, but now I think it makes more sense to be even more human-centered because the barriers to use AI have fallen through the floor. It doesn't have to be people in this room. It could be your 10-year-old child, it could be your grandparent, it could be the cab driver. Last taxi ride I took, somebody was asking me, what classes should I take? Should I take data analytics? Where should I be moving to? And then I think about this more just because of the phase of my career, but what is the potential impact if you succeed? Who's going to adopt it? Who's going to care? And what other things are going to go on that slide when I say, what's my legacy? Or what's your student's legacy? So this Heilmeyer Catechism, it came from DARPA. He ran DARPA, George Heilmeyer ran it from 77 to 79. If you ever going to help a program manager pitch a new program at DARPA, or actually a lot of the funding agencies, if you don't have answers to these questions, you will not get funding. Even if you have great answers to these questions, you might not get funding, but you have to have answers to these questions. So, what are you trying to do? No jargon. How's it done today? And what are the limits of the current practice? What's in your new approach that's new, and why do you think it's going to be successful? Everything other than the why now is directly from the DARPA website. I kind of think about the main essence of this is why now. And then who cares? And part of that is who might fund it? If you're successful, what difference will it make? And then what are the risks? How much is it going to cost, both in time and money? And then how long will it take? And how are you going to evaluate it? When I got to Stanford in the 90s, Frank Fernandez was in charge, and he was like Mr. Metrics. So it's always about how are you going to evaluate this? And lots of these metrics were like super granular, kind of boring. But what are these final exams to check for success? I don't think AI has this solved, despite the fact that there's a proliferation of evaluation environments, despite the fact that there's all these benchmark leaderboards, despite the fact that, everybody's trying to go against some number of benchmarks. I think we need deeper, stronger evaluation environments to really do this exam. And I don't have an answer to that, but I think it's an open problem. So a few reflections. In hindsight, I've been aligning my passions for my entire career, where I'm a geek at heart. Actually, I think one of the reasons that I'm successful is I talk well, I interact well with geeks, and I also can dress up and interact well with check writing managers who don't speak super geeky stuff. So those applications are still compelling for me, and actually I think that's one of the reasons that I still interact really well with geeks, although I'm not as much of a geek anymore. Although I was just talking to people who are using the tools to do coding, and they're like, well, you could get back to being a geek. You could get back to coding because it's not going to take you as much time because you got your 10 assistants out there coding for you, and all you have to do is do really good prompts. But also, I love working in interdisciplinary and hybrid settings. And one of the reasons that is so cool, other than I get to learn all sorts of new stuff, but most of us in this room, I think, still care about publications. And when you work in interdisciplinary settings, you get to double and triple publish ethically. Like I'm published in pediatric journals, in immunology journals, in nanomaterial journals, and programmable metamaterial journals, because I've been working in all these different areas. So not only does it give me extra sources of funding, but it also gives me extra numbers of requirements. And usually when I get requirements from a couple places that at an abstract level are the same thing, that's where I might get an interesting breakthrough and like a fundamental important paper that other people might care about. And then also, it's just wise to have, to be politically and or funding aligned. So when I worked at Bell Labs, I was preemptively funded. I got my time for free, and if I wanted programming support, I had to defend that with kind of a spreadsheet showing potential impact. These days, where I have a decent sized group, now I have to think about how I'm going to get that group funded, and the funding landscape is changing, so I have to think a little bit more about that for where proposals have a better chance of not getting knocked down and better chance of getting funded. And then ultimately, I took over this lab at Stanford that was started by Ed Feigenbaum, and he told me that he started the Knowledge Systems Lab to work in an environment that he wanted to work in, with people he wanted to work with on topics that he wanted to work on. And that's what I try to do, and that's the way to stay motivated, for me anyway, to stay motivated for life. So I want to work with great people who make me better and my work better, but I also want to add value to them. And then I really want to have the potential to have lasting value. I think about places to apply my stuff. I do a lot of precision, personalized medicine, because although I never got an MD, I can have more influence helping make recommendations for diabetic patients than any endocrinologist who serially sees one patient at a time. But if I've got systems that can be deployed broadly, you know, I can make, make America healthy again. I don't know, that acronym. I love the spirit. I wonder about the messenger, but, you know, but that notion of, you know, having lasting impact with technology, I find really compelling. Okay, so that's kind of a long preamble, but the next steps are, I'm going to give a few examples from history of how those principles and decisions played out, and many of them played out well with longitudinal impact. Give a few examples from current directions that might be applicable to a broader audience. One example of how I'm pretty radically changing my teaching. And I think we all, anybody who's a professor or, you know, an instructor or just has mentees, you know, we all have to think about how we teach today and what kind of information we're passing on to the next generation. And then a couple topics that I think as a community we might want to discuss. So every place there's opportunities and challenges. When I got to Bell Labs, I moved quickly into pure research, into a description logic reasoning group. And we did next generation knowledge representation and reasoning systems. We had to earn our keep. We had to pay for those programmers. So we did real applications, building these giant configurators for multi-million dollar, multi-tens, and sometimes hundreds of millions of dollars of products. So we had description logic reasoning embedded in products, and there was a help desk behind it. And the help desk was massively not prepared to answer any questions about description logic's reasoning. And I was still low on the totem pole now. So the questions went into the help desk, they went into the tier 1 help desk, they went to the next level, tier 2 help desk, the person who had more training, tier 3 help desk, couldn't answer the question, went back to applied research, they couldn't answer the question, came back to me in pure research, and again, I'm the low man on the totem pole or low person on the totem pole. So I get these questions of, why am I ordering this $50,000 part given my set of 300 requirements? And I'm like, I'm going to die. I'm going to either kill people or I'm going to build systems that can do this themselves. So, and AT&T was paying for my, my thesis work at the time, so I did explanation in description logics as my thesis topic. And at the time, nobody did explanation in description logics. It was not uncommon to do it in expert systems, but they were pretty not compelling. They were pretty much trace dumps that debugger people might be happy with, but you know, normal humans didn't want to see that. So the thesis came about to make description logics usable by a broader range of people, and not just those trained in description logics and formal reasoning. And you know, it was easy to see that there was a gap. There was no literature on explanation and description logics, but it was because of actual usage, and I had good use cases and good test cases for evaluating it. So it yielded publications. I got a thesis out of it. Ended up getting a number of patents out of it as well, and it influenced some academic and commercial products. I went to visit my friend Jim Hendler, who was at the time at University of Maryland. He actually wasn't there, but his group was there. They were working on Pellet, and early, it was a description logic, or turned into a description logic reasoner. They didn't have explanation at the time. After my visit, they started that. They did a startup company. Now it's hard to get, it's odd to get a semantic web toolkit without a significant explanation component in it. It also resulted in patents, which I ended up being noticed by patent attorneys, and I ended up doing some intellectual property consulting. So it opened opportunities for me, and I figured if I'm going to be an inventor on patents, I want to see the other side. I want to see that litigation side. I ended up doing some amount of consulting when I was at Stanford. Anybody who lives in the Bay Area and knows anything about Stanford's pay scale, you're not going to make enough money from Stanford, especially when I was there, but it's still true now, if you either weren't independently wealthy, don't have a startup on the side, don't do some consulting on the side, if you want to live close by. So it opened up intellectual property consulting, which also then helped to get me kind of inspired by additional sets of requirements and concerns that people had. So I'm kind of always in this requirements gathering mode for what do people need and what would be cool to work on. And then explanation's been a theme of my work since forever. I've got currently 8 graduate students and 2 research staff. I don't think anybody is doing any systems that don't have some portion of explanation in it. One pretty recent graduate student, Sruthi Chari, did an explanation ontology, which has been reused and has seen increased citations. You know, one of the things that I love about Google Messages is I can see the citations that are increasing, and things like the explanation ontologies and fairness metrics ontologies and my benchmarking toolkits, they're starting to explode again. And when I see explosions happening on certain areas of research, you know, I know that it's a good path for I and my students to take on. Okay, so Stanford opportunities and challenges. So I went from proactively funded research where I didn't really have to work for my money. Well, I had to deliver for my money, but I didn't have to work to get funding for my salary. But at Stanford, I had a research leadership position, so I had to fund a pretty big payroll. There was like a little bit of money when I walked in the door, but it was almost all from one and only one source, DARPA. And then DARPA was pretty stable money. It was big budgets, and you didn't usually, if you got an award, you got to keep it for the full duration that they were going to give it to you for. But nobody should work with a sole source of funding. So I diversified funding, went out and got industry funding, I got foundation funding. I used vehicles. Stanford has some amazing infrastructure that not everybody has, like the Computer Science Forum that helps you bring in industry money. And it brings in a whole lot of additional kinds of requirements that might motivate your work. But then I also leveraged the environment that I was in. You know, when I was in basically the suburbs of New York City and New Jersey, I participated in New York events like the New York New Media events. I played tennis with the leadership, which was kind of cool, so I understood what was going on at Bell Labs. But at Stanford, there were just a gazillion networking options. So I didn't have any intention at the time to start a startup, but I took this night class on how to start a startup, which was a pretty amazing place to take it because the different venture capitalists from Sand Hill Road would come in on different weeks and give you lectures on how to do a term sheet and how to get customers, how to build your pitch deck. So even if you're not going to start a startup, if you're going to consult a startup, it's useful to know that. But those are tools that actually help you get funding, even if you're going to be a pure academic for the rest of your life. And then sitting in the Gates building close to Sand Hill Road, running the Knowledge Systems Lab was an amazing network opener. So use the environment that you're in. It's hard to compete with the Stanfords and the MITs of the world for kind of amazing platforms from which to work, but find something that you can leverage wherever you are. So, RPI is not that level of integration work, but one of our alums is an NVIDIA co-founder, so Curtis Preem. There's always somebody that or something that you can find a way to leverage in a way that's win-win. So a few more on opportunities and challenges at Stanford. So now I had technical input from a lot of places. So it used to be that I only had the technical input from AT&T research, which wasn't too strong. As long as I got some good publications or I made a difference to the company, I was solid and my group was solid. But now at Stanford, I had funders from a wide range, well, because I diversified. I had a wide range of funders that I needed to satisfy, and it ended up motivating a lot of proof and trust work because the funders required deep explanation and provenance work. I had funders who came to me and say, yes, you do beautiful ontologies. Yes, you do great knowledge representation and reasoning systems. But if you can't tell me where that information came from, i.e. the provenance, and you can't tell me who else in my organization trusts it, I'm not going to use your stuff. And by the way, I'm not going to renew your contract, which means you're going to have to fire people right after I just got to Stanford. So I turned into a provenance researcher overnight. Also, we still have these. They used to be called go, no-go challenges. Pretty much if you're going to have government-sponsored research money, at least big research money, you usually have some set of evaluations where if you don't make it through, you don't get your next tranche of funding. And so I put in place a lot of testing environments. So we had gaps, significant gaps, in pragmatic evaluation and transparency support. So I walked in the middle of the high performance knowledge base DARPA program, and it was probably a $4 million budget at the time. I was about to, so walk in the door, I'm about to go into a go, no-go situation where I have to answer a lot of questions based on really suspicious knowledge bases that were generated by people, hand-generated by people who had very little training. And I just kind of glanced at things, big knowledge bases, and figured out that I couldn't personally clean them up enough to be able to answer the questions well. So I built this, well, with the help of programmers, I built this thing called Chimera, a multi-headed beast that did diagnosis of ontologies and knowledge bases. Like, what kind of problems can I guarantee that at least you don't have these, and then it's extensible. So I can add new things to test for. So let's at least make sure we don't have, this was a while ago, so we don't have things like Bill Clinton, who happens to be both a person and a country, or Iran, who happens to be both a person and a country. So I don't want to be instances of two disjoint classes. So, and we did pragmatic approaches, like what information can I get to easily that I can test? And then what kind of assurance can I give you that at least I don't have these kinds of problems? That also started Inference Web, which was explore the inferences that are done, do proof trees, and also markup languages that keep track of where information came from and provide explanations of things like entity extraction. And these are all motivated by large, multi-million-dollar government-sponsored programs. So some takeaways. Actually, each of the examples that are remaining, I have takeaways and opinions. So I think testing harnesses are even more critical today. Chimera ended up providing sets of tests that I used, that other people used in academics, like Protégé and OOPS. They got integrated into standards organizations, like the OMG has this set of hygiene tests that now we have integrated into our GitHub infrastructure at RPI. And as a result, we had better knowledge bases and better ontologies. And things like on September 12th, I got a call from somebody in the intelligence world saying, "Hi, would you like to help your country? Here you have high quality knowledge bases of weapons of mass destruction and terrorist groups." And then I helped them, and that went into some dark place that I can never see, but I'm told that it got integrated into systems. And part of the reason that it lived on was because I could tell the world what kind of testing was done. Also, after the DARPA programming assistant that learns, we had these large ontologies that Siri ended up using in the initial rounds of the spin out of Siri. The proof and trust work ended up providing requirements for the World Wide Web Consortium, kind of the standards body that most people go to for ontologies and semantic web. So it ended up being a significant contributor to recommendations for provenance on the web. And the work on explaining entity extraction and working with massive data ended up influencing UIMA, the Unstructured Information Management Architecture at IBM, which formed the foundation of Watson. And I'm going to show just a little bit in user-centered explanation. I'm going to skip this for time. So a couple of examples of hybrid AI and interdisciplinary settings. This was IBM AI Horizons Network funded. It was a program called Health Empowerment by Analytics, Learning, and Semantics. And one of the reasons I put this up, it's completed now, but this general notion of pulling together machine learning informed by semantics, and deep learning using graphs, and personalization, all with information, semantics kind of helping do the integration, I think is going to continue on for the foreseeable future. We had an ontology-enabled framework. This architecture has been used underneath that platform, but underneath a lot of other platforms, pulling in information either through mostly automated ingest from literature and databases, all orchestrated through the knowledge graph and ontologies, with pluggable components for different kinds of reasoning. You could add a new component. Users can ask questions through the cognitive agents. They can ask directly, and all have it kind of orchestrated through the semantics. Then ways to do knowledge graph construction. We built this food knowledge graph that also the citations on this are starting to go up. So you get information from places like the USDA, pull in information. This was structured information, but you're going to have to align it. So we did some through a semantic data dictionary-based alignment strategy and some through an embedding-based alignment strategy. Aligning with some best practice, large collection of best practice, wide range of ontologies, and built a knowledge graph that actually is seeing a fair amount of reuse, even though it has been through our testing environments, even though it's not really anywhere close to perfect, but it's an integration that is transparent and reusable. And then ontology-enabled approach for user-centered and knowledge-enabled explanations of AI, I think is a place that more people should be working. I'm going to repeat some of the things that Guy said in his first talk. Please pick up some of these ideas. I mean, no one group can do it all, but we need to combine explanations from multiple sources using a whole lot of different AI methods. This was Shruti Chari's thesis, but others of us contributed and did work along the way. We designed this meta-explainer framework to respond to a large variety of questions using simple approach. decompose, delegate, and synthesize. And we leveraged the explanation ontology that served as the symbolic component for the meta-explainer. And that explanation ontology, it was born out of the HEALS project, the Health Empowerment Using Analysis, Learning, and Semantics. And we were in a healthcare provider recommender system. So we interviewed a bunch of healthcare providers and said, when are you going to use the results of our system? And what kinds of explanations do you want to see? And we found that essentially when they were surprised, that was when they needed an explanation the most. And they didn't need a perfect explanation, which was good because, I'm skipping through the animation, which was good because we had a lot of learning components in there, and nobody wants the full basis of what the learner did. But if you can see what influenced the outcome more than other things, that actually was useful for them. So we needed to answer questions like, why is the patient's A1C important in their diabetes? And we have a lot of different components that interact with that. And then we want to have explanations that can come out in natural language. So, we used some best practice. She defended, I guess, a year ago, so this is all slightly behind. But we wanted to be able to do different kinds of explanation types, and the kinds that the users found were going to be most important. They really liked case-based explanations. They really liked contrastive explanations. So what if I do this versus that? They really found a lot of benefit in counterfactual. What if I don't do this? What if I don't give this person metformin, which is kind of a first line of defense if you've got a standard diabetic diagnosis? And then what's your rationale for doing something? Of course, use things like RAG. Of course, use tools that are available to you when it makes sense. And then we did a combination of literature-derived, these are thesis students, so you have them do a good literature survey, find all the kinds of explanation that you can find out in the literature today, but then also find out what's important in your settings. So the ones that we found were the most important for, that's right, I've got, for the setting in healthcare was the rationale and the responsibility and the case-based, contextual, contrastive, and counterfactual, and the statistical. And we did multiple rounds of interviews with potential users. And every explanation comes with a definition, the equivalents, and some prototypical questions. And we do a couple of kinds of support for that. We have an extensible explanation ontology, but we really focus on the kinds of explanations that users thought were the most valuable. So a couple of takeaways are flexible hybrid explanation architectures are, I think, a direction worth exploring. Extensible ontologies, like the explanation ontologies that are grounded in actual use cases, can provide a good foundation. More work in this area, I think, will continue to be fundable and publishable. And continuing the user-centered focus is something that I think our field needs to do. I've got two more examples of places that money flows. So this environment-driven conceptual learning, it was funded through the DoD and the intelligence community. They want robust and automatic analysis of large amounts of multimodal data. And this actually, I've been doing this actually for decades, often government funded. But now this is creating AI agents capable of continual learning, but now vision is integrated. And explanation was unbelievably important here. And so this last statement is from the government. ECOL, their program, will transform current machine learning approaches by developing algorithms that can identify, represent, and ground novel attributes that form the symbolic and contextual model for a particular object or activity through interactive learning with a human analyst. I bring this up because even though this program sadly ended early, because, oh my God, ChatGPT 8.0 might do what phase 2 of this program was going to do. Such a sad statement. But the fact that it got out the door, I think this is representative of money that still flows. And, that's important for any academic in the room, whether you're a grad student funded by a professor or trying to get money. This had an integration component. I ran the semantics, a language person ran the language portion, and a vision person ran the recognition. And then there was a graph-centric multi-agent system sample architecture that we did in this. And the agents continuously contribute to the graph, and then the graph orchestrates everything. So the dialogue system is how you interact with it. The agents make API calls, and the knowledge graph can answer questions about why it believes this is a truck, or it isn't a truck, or it has a payload that could explode at any moment. And we needed to answer questions like, why do you think this? Which I was, again, super excited about. And it was defending, our troops. So it didn't have the hot buttons that, you're likely to see cancel programs these days. And this wasn't the interface that we had in there, but we have this probability-aware knowledge graph back end that can answer questions of perusing the graph, and we put it in 3D environments, and you could go from any particular node to another node and know why it might get there and what probability it might get there with. So a couple takeaways from this. I think these diverse and hybrid component architectures are emerging and will continue to be fundable. We just got a new program, yay, in the door, Army's program on collective judgment formation. It's through this collaborative research alliance, and it does basic research to expand scientific understanding of human-agent interactions. One of the things that's cool is, how do you work effectively with bots? This is in an intelligence setting, but how are you going to convince the intelligence analysts to work well? How are you going to get this collective judgment formation in a way that the group thinks is going to survive? I think this is actually a model that will continue to be something where programs are going to come out that can support our research. So that's just in the door. The kickoff meeting's actually next week. I just submitted 2 MURI proposals that this was topic 10, ontology engineering for machine learning and open-ended sensor model user systems. So Army's MURI programs supports fundamental research, inherently multidisciplinary. I'm working with people on both of those programs I've never met before in areas that, I don't really do sensor work. I do some machine learning now, but it's wildly interdisciplinary, and I think this is part of the future. So, you've got to look around at places that can fund work that you want to do that you think are going to make a difference. And knowledge graphs, in my opinion, continue to be central to enabling these diverse applications that support transparency and explanation. I'm going to go only through a couple of these slides. We create sandboxes for exploring. So we did this one a little bit ago, ChatBS for checking the bullshit that comes out of ChatGPT. So you ask questions a bunch of times. You say, why do you believe this? Get it out in a format that I can use, like in RDF, because I'm a semantic web person. Who is Deborah? You get a lot of different answers. I put this up even though it's using an old version of ChatGPT because the new one won't answer this anymore. But the old one, what awards have I won? Oh my God, it said I won the Turing Award. Super good. Yeah, by the way, I didn't. And the weird thing is, I've never written a paper with this guy. I have written papers with some Turing Award winners. I don't know what the evidence was that I won the Turing Award. And later, if you asked it, did Deborah win the Turing Award? It said no. And the new one won't answer that question. But how are you going to figure out whether it's something that you can believe or not? So we have this fact checker demo that, submits prompts, uses continuation API. Then the new graduate student wants to do kind of a unit testing based fact validation. and create automated workflows. So he's doing it in our diabetes settings, make some recommendations for good foods given a patient's age, food preferences, and diagnoses. So how am I going to check that? And how am I going to create an architecture that's going to automatically create it for me? And then, so the user puts in a natural language text. We have a prompting template that creates the prompt automatically, creates some sparkle currently with some aid, does some post-processing, create some test environments, create experimental runs, and then now can explain how that experimental run was done. And I'm going to skip that for time, and create some explainability modules so that you can see what's actually going on. And then I'm building these assessment protocols everywhere. This was both an interesting and challenging program. The DARPA Machine Common Sense program, I was brought in to build a common sense knowledge graph to help make it through the benchmarks. But guess what? And this was actually a couple years ago. The language models were killing the benchmarks before they ever got close to my knowledge graphs. So didn't need the knowledge graphs, but we needed better assessment protocols. And we tried to put context in and tried to put more understanding in these more complex assessment environment. And so we did this for conversational systems. So a couple takeaways. Benchmarks are everywhere. They were all over. This program was started by Dave Gunning, who maybe not so debatably was my favorite DARPA program manager of all times. He had what I thought were semi-adequate benchmarks for years 1 through 4. The language models started to kill year 4 benchmarks in year 1. So we had to pivot. Fortunately, I didn't get pivoted out of the program. Fortunately, it got to pivot around to doing a different assessment protocols. And fortunately, I convinced there was a new program manager who took over that we needed to think more abstractly about the kinds of evaluations that we were doing. I think it's also time to explore a wide variety of architectures for testing harnesses. I'm doing some. I think everybody should do some. And I firmly believe that graph-powered hybrid AI is the future, including for graph-powered hybrid testing. So last component. I'm teaching this class, just started last week, for graph-powered hybrid AI. I think graphs are going to continue to provide critical additions to hybrid architectures. I can't keep up with the literature. I don't think even the youngest people in this audience who still have maybe more time than I do as a fragmented professor, I don't think anybody can keep up with the literature. And I also think that teaching needs new models. So this is the abstract on my page, that you're going to explore the emerging field of AI. So, we combine rich structured representation with language models. Then we're going to look at theoretical foundations, but also practical applications. And we're going to develop skills for critiquing, designing, and implementing and evaluating and utilizing hybrid AI systems. I have the benefit of teaching a small discussion class, but we're doing this in a Toastmasters style. So we're doing class discussion. We're identifying which papers to read. I and one other person have identified the first set of candidate papers to read. We're assigning just for the first 2 weeks those papers, and then after that, the class will decide which papers we're going to discuss, and the class will come in and propose papers to read, and they'll make a pitch for why we should be reading that paper and why it makes a difference. And one of the reasons we're doing this is because in the 13-week term, I'm sure that some important papers are going to appear. And they might not be peer-reviewed papers. They might be some blog post someplace. They might be an opinion piece in the New York Times or whatever. So we want to try to keep up with it. And then we're modeling this. I don't have any TAs for this. So I'm trying to figure out how to do evaluation and also how to teach the students to do evaluation. So this is a picture on the right side of a piece of a Toastmasters meeting. There's some person who runs the meeting, so one of the students is going to learn how to run the meeting. Then Toastmasters uses this phrase of table topics, but we have lightning talks for students proposing a topic to discuss next class. And then we have designated evaluators to see how well the student presented both the work and also their presentation skills. And then we have somebody taking the notes on what the actual takeaways were. So we have these groups of people. Somebody runs the meeting. There are a couple people who do prepared presentations. There's a debate, there's evaluation, and then there's lightning talk proposals. One team leads the discussion, another team leads the evaluation, another team leads the takeaways, and another team monitors the contributions. And finally, the students propose the lightning talks for the next week. It's a total experiment, but it's trying to decrease my grading time because, that's tough. It's trying to help students learn how to identify emerging literature that should be discussed. It's teaching people how in a short period of time, you get a lightning talk, max 3 minutes. Sometimes we're going to do 1 minute. How you can make a pitch for why this is important, and also how you can run a meeting. And eventually, so it's too soon to tell, but the students are currently saying positive things. We'll see what happens in a few more weeks. It works for small classes. I'm trying to have fun, too. So I think if you're going to stay in a field for a long time, if you're not having fun, eventually you're going to get out. And as long as I'm having fun and I'm making a difference, I'm still staying there. So I'm trying to address my need to stay current, but also the students' needs to stay current. I'm trying to teach the students how to lead meetings, evaluate critically, how to do paper presentations, how to moderate discussions, and minimize the grading burden. Okay, that is the end of the teaching piece. So one last slide. I think hybrid AI is here to stay, and it's going to continue to evolve at a speed that none of us can keep up with. Explanation continues to grow in importance, so don't ignore it. Graph-powered, semantics-aware, context-aware coordination, I think will continue to be a place that we should explore. You've got to be, well, I hesitate to say you've got to be. It pays to be adaptable and resilient. I have certainly done a lot of pivots in my life, and I've been one of the best funded academic researchers that I'm aware of in the United States and maybe in the world as a result of that. So also thinking beyond the next publication or the next benchmark, moving to thinking about new approaches is something that can help at any level, but certainly at a professor level, but really even at a grad student level. And then this new teaching style, I think we all have to figure out new teaching styles. I mean, I'm telling people, go out and please use large language models. When they first came out, I was evaluating on synthesis, so I didn't let people do it for the first couple weeks and then said, that's probably not a good plan. So thinking about what your teaching style is going to be and how you're going to create people who learn from you, who are going to be valuable for years to come, is an art and a science. And funding models, wow, they're evolving at a speed that is also a little bit interesting, and we need to evolve too. So with that, I left at least 10 minutes for questions, I think. Thanks.
Thank you so much for this very exciting talk. And as Deborah said, we had time for questions. So those who have questions can come here and ask. Yes? Okay.
Well, thank you, Deborah, for an inspiring talk. This last bit that you just got into with regard to innovating in the context of teaching and learning and trying to bring in some of these technologies and techniques in this context. I know my advisor, Paul Groth, has been thinking about how that kind of thing can be applied to the context of running a research lab. And since that's kind of adjacent to some of the things and the ideas that you're talking about, I was curious as to what your thoughts might be in terms of how this kind of thinking applies to changing how a research organization at this kind of lab scale of tens of people would be able to kind of progress effectively in the future.
Yeah, great question. And I've been thinking about that a lot as well because I travel too much. And so my research group, every week we have a research meeting. Every month, a different student runs the research meeting. I ask them to post what they would propose to do. I review it, but they actually run the meeting. And they also take input for, what next week is going to be. So actually, my research group has been running a little bit like this for since I realized I was going to miss too many of my own meetings. I had to figure out ways that other people could run the group, and also it would teach them skills. So, and also, I can't keep up with enough of the literature. So there, I've got some super energetic graduate students who I don't think sleep. And I think they read faster than I do. And they're so motivated. They bring me an awful lot of really interesting stuff. So we as a group figure out where we should be going. And I also, these days, I still have a lead on a lot of the proposals that I'm writing, but I'm increasingly having more of my people write more of the proposals, both because I have to write more proposals these days. The hit rate has decreased, my experience anyway. And so I got to get more proposals out there to get more money in the door. Plus, even if you're not going to go into academics, it's useful to understand what it takes to write a proposal. So I've distributed more of the proposal writing, more of the funding gathering, more of the slide presentation work, more of the discussion facilitation. And it's diversified the research ideas that I end up pursuing. And in reality, I think if you're a good advisor, I've advised topics that I know nothing about. I had a PhD student who did a mobile-aware, description logic-based advisor for his thesis. I knew nothing about mobile computing. I didn't really know what it took to be power aware to get something to work, and he did it on Androids and on iPhones. So I can advise topics in areas that I know how to ask good questions. I know how to be a Socratic instructor, well, tell me more about that. Or so I think your students, it's rare that my students don't teach me more than I teach them. I teach them more of the things that I've got deep experience in, but they broaden me. So I think it's a good way to have a learning environment.
Thank you so much for being here. Your prelim, as you described it, was really, really motivating. I wanted to ask more about how your fellow teachers have responded to you kind of changing your radical teaching program, because it's very exciting to hear about, but I'd like to know what they say.
Well, it's soon. Classes just started last week, and actually I have to give a red RPI's color is red, and so the alumni comes in and they get 3 talks from distinguished professors, and I have to give one of those. And the topic that I've been assigned is education in the new AI world. So I don't really have much feedback yet. Although the few people who have exposed this to, they're like, oh my God, that could decrease my teaching load. That could increase, the students' breadth of learning experience. So everybody's been positive so far.
Is there a place to watch that talk when you give it? Is there a way I could see it?
Probably. Probably not in real time, but they'll probably tape it.
Okay, I'll be looking forward to it. Thank you.
Sure.
Any further questions? We have time for a very short one. Oh, yeah, come please. Thank you.
I guess I could ask a quick question. Fantastic talk. So I'm always curious on how best to teach students, and of course, with the changing landscape of LLMs and all of that, I took kind of a similar approach that I think people should embrace it in some sense and use it in a way as a tool rather than as form of cheating. So coming up with different problems and different techniques. One of the issues that arises, and you've talked about it briefly here, was that as the class size grows, it becomes more and more difficult to have interactive methods for teaching. I was curious if you've thought a little bit more about it. Do we have to change how we structure classes? Is it no longer just lecture-based, it's now more lab-based or smaller group-based?
Yeah, I mean, I think a lot of my colleagues, I'm lucky because I'm an endowed chair and I get to say, no, I'm not teaching that 250-person class.
Right.
But I think we have to turn things, I mean, there's the inverted classroom, right? So, I mean, that's starting to happen. And I explored this with a little bit larger class than this, where they graded each other and then they defended their grades and they did kind of an open review kind of mode, because I think we have to change. We're not going to be able to do oral exams in 250-person classes. We're not going to be able to do this discussion level, but we are able to do it in groups. When I first went from Stanford, where I had a position that I was allowed to teach if I had time, but I wasn't required to teach. One of the pieces of advice that I got was do group projects quickly, because it cuts down your grading requirements. But then you've got to figure out ways to make sure that they're not cheating, or one person's not carrying more of the load. So I've put in place where now I want you to use large language models, but I need you to tell me how you evaluated the answer, what you found that wasn't right, because the chances that everything was perfect are near zero. And then what you did to expand, enhance, if you did some updated prompt, what you did to do that, and what kind of evidence you're going to provide for other people to believe that you did your due diligence and that they should believe you.
Yeah, and I think there's like a weird gray area on like, you're saying you say, I need to provide the prompts that do this. Like, where's that gray area of it's just cheating where you're just having that, a very simple prompt give you the answer to the solution. So I think it's a discussion that isn't going to be solved here, but I think it's a fun thing to talk about. Yeah, thank you.
Sure.
Okay, let's thank the speaker. Thank you so much for your very good